Hello everyone and welcome. In this video we are talking about how Audi is eliminating turbo lag through the use of the world's first production electric supercharger. So traditionally superchargers are run off of the engine. In this case the engine is powering a 3 kilowatt generator, which is powering a 48 volt battery, which is then powering a 7 kilowatt electric motor, which is powering the compressor side, that compressor to pull in additional air to compensate for turbo lag. So Audi is calling this an electric powered compressor. You can think of it as an electric supercharger, where instead of the engine driving it, you have an electric motor driving that compressor wheel. So first I want to talk about the airflow. Looking at the engine, it can look a bit complicated as what's going on. So I've broken it down here on the whiteboard so we can kind of figure that out. So initially you're just pulling in the air through one of those turbochargers. So you've got your air filter, the air comes through that first turbocharger, a valve for the second turbocharger is off, blocked off, so you can't have air coming through there. That air then travels split between two different intercoolers, and then at this intercooler, this valve will be open right here. Let's say we're not using the electric supercharger, then the air passes through, combines, and then is split between the two intake manifolds for each of the cylinder banks. Then it goes from all 8 of these cylinders to this single exhaust right here before passing out the back. Now we'll get into the different stages as it gets into higher RPM, but essentially how this electric supercharger works is when you initially press on the gas, you want that instant response. You don't want turbo lag. And so that's where the electric motor comes in. In less than a quarter of a second, it can spool up to 70,000 RPM and provide that immediate boost to fill the delay of turbo lag before the main turbocharger has started spooling up. So you'll have this valve closed off right here, and then the compressor wheel will pull air directly, push that into the 8 cylinders. Now that's when you initially press on the gas. As you start to get into, those low to mid higher RPMs, the low to mid RPM range, then you start to just rely on the turbocharger itself once those exhaust gases have been built up and you no longer need this electric supercharger to compensate for the lag. So then you're just running on this single turbocharger. And then as you start to get to that mid-range RPM into the higher RPM and you're still asking for full power, they've actually split now where they'll power both turbochargers. And in this case, you'll have air coming through both of them. This valve right here will be open, so you're now pulling in air through both turbochargers. You're powering both turbochargers, and you'll have sufficient boost for that mid to high RPM range while operating under full throttle. So they've also done a super clever thing here with the exhaust valves. And so the way it's split up is on the low RPM side, you're only using a single exhaust valve for each cylinder, and all of that air is being routed to the first turbocharger. And then there's a variable valve system which will activate the second exhaust valve, and that second exhaust valve for each cylinder goes to the second turbocharger. So each cylinder has one exhaust valve that powers each turbocharger, and you'll just use the one exhaust valve for those low to mid RPM ranges, and then you'll use both exhaust valves to power both turbos for that higher RPM region where you want more power and you want to be able to take advantage of using both turbos. So it'll act like a single turbo engine, low to mid, and then mid to high RPM, it will act like a twin turbo engine as it splits that exhaust gases into both of them. Now, a lot of people wonder why you can't just slap on an electric turbo on any car. You've got a 12 volt battery system. Why can't you just use that to, bring in more air? And really it comes down to power. So those, there are aftermarket ones that'll say like it's an electric supercharger and it's powered off your 12 volt battery. Those are nonsense. They don't have enough power to actually do anything. And so that's what I kind of want to discuss here. So the reason Audi put in a 48 volt system is to be able to power this 7 kilowatt motor. You need a significant amount of power to pull in a lot of air and to do that very quickly. So power is equal to current multiplied by voltage. So if you have 145 amps, you multiply that by 48 volts, which is what this battery delivers, and that gives you 7 kilowatts or 7,000 watts, about 9.5 horsepower. If you're using a 12 volt system, you've got 145 amps multiplied by 12 volts, you're only producing 1.75 kilowatts. And this is a huge demand. Your car battery already has plenty of things it's powering. All the onboard electronics, your HVAC system, plenty of different things, your sound system. So it's got its responsibilities on the car, the spark for the engine, in the case of gasoline engines. It has its responsibilities and considering, the idea of putting on an electric supercharger on top of that just simply isn't feasible. There's not enough power to do it. So that's why Audi has added this separate 48-volt system. And this means adding a lot of stuff to the engine. This is why it's not done on every car out there, is because it's expensive and it could, it's of course complicated to do. So you're adding, you're adding a generator to the system. You're adding a 470 watt hour, 48 volt battery to the system. You're adding that electric supercharger to the system and all the associated piping that goes along with it. And you're also adding a DC to DC converter, 48 volt down to 12 volt for other onboard systems. And this is all in addition to the 12-volt battery system that's already on the car. So, this isn't something that can be cheaply done, hence it's in, a super nice, expensive Audi SQ7, really nice, quick SUV. And so, in a more expensive car, it makes sense. In cheaper cars, it's not a simple solution, as of the added complexity and cost that goes along with it. But I think one of the really important things to understand is that it takes a lot of power to do this. It's not something that you can, depend on a 12-volt battery to do for your car. So if you guys have any questions or comments, of course, feel free to leave them below. Thanks for watching.